Hi, welcome to my video on find the coordinates of a point if a function is continuous. Number 1, find the coordinates of a point if it's continuous at x equals -1. And we have the function t of x. X is greater than or equal to -1. We have a linear ax plus 6. And where x is less than -1, we have a quadratic x minus 3 all squared minus 2a. So if it's continuous, it means the limit of the t of x as x approaches -1 on the right side. So this is the t of x. So that's the limit as x approaches -1 on the right side. On the right side is greater than 0. So we have ax plus 6. And the limit on the right is going to equal the limit on the left if it's continuous. So let's put a -1 in the place of x. And we get -a plus 6. So let's look at the limit of t of x as x approaches -1 on the left side. And so as approaches a -1 on the left side, we have, this is on the left because it's less than, so we have x plus 3 squared minus 2a. So we'll sub in -1 in the place of x. And we have 2 squared is 4 minus 2a. So because it's continuous, that means that the limit, the t of x, as it approaches -1 on the right side is equal to the limit of the t of x as it approaches -1 on the left side. So on the right side we have -a plus 6. On the left side we have 4 minus 2a. And when we solve this, we move the variables. We got -a plus 2a. And 4 minus 6, so a equals -2. So that's the value of a, so we want to find the coordinates at the point. So we look at the limit as the t of x approaches -1 on the right side. So that limit is ax plus 6. So as x approaches -1 on the right side, so that, and it gives us a -a plus 6, and a is -2, so we have -2 plus 8. The negative of a -2 is 2 plus 6. I said it. Negative of a -2 plus 6. I was giving 8 as the answer. So at the point, the x value is -1 and the y value is 8. And so that's the point that is continues at -1. So let's just check that. Let's check that in the limit on the left. The limit on the left is 4 minus 2x. So 4a is -2. So 4 plus 4 is 8. So on the left, x is -1, so again on the left is -1, 8. So that's true. So that's the point where it continues at -1, -1, 8. Find the coordinates at the point if it's continuous, and it's continuous on the d of x at x equals k. And again, on the right side, we have kx plus 6. On the left side, which is less than, we have x squared plus x plus 1. And again, to be continuous, the left side has to equal the right side. So the limit of the d of x as x approaches k on the right side. So that's the limit. So on the right side, we have a kx plus 6 as k approaches k on the right side. So on the right side, we have, so that's a k. So x is a k, just a little bit different. Instead of In previous ones we had numbers here, but now we got a value of k. So that's k squared plus 6. And we need to look at the limit on the left equals the limit on the right. So let's look at as it approaches k on the negative side. So that as approaches k on the negative side. So on the negative side is less than. So we have x squared plus x plus 1. So we put k in the place of x. So we get k squared plus k plus 1. And if it's continuous, which it says it's going to be, the limit on the right of d of x is equal to the limit on the d of x on the left side, k to the negative 1. And so we have, on the right side, we have a k squared plus 6. On the left side, we have a k squared plus k plus 1. So the limits are equal. The k squared cancels out. I'm going to leave the k there and go 6 minus 1. So k is 5. So if we want to find what point that is, let's take the limit of d of x as it approaches. Again, I'm gonna come up with this value here. This x equals k. So that comes out. I already got it worked out as k squared plus 6. So that's a 5 plus 6. This k is approaching 5. So we do the limit on the d of x as k approaches 5. So we put a 5 in. So k is 5, so we put a 5 into this k, and we come up with 25 plus 6, which is 31. And again, to check that, k is 5, so let's look at the limit on the left. So the limit on the left is k squared plus k plus 1. So we got a 5 squared plus 5 plus 1. 25 plus 5 plus 1 is 31. So a 5 gives me a 31. So the point here is 5 giving you 31. So the point here is 5, 31. So the value of k is 5 to give me the coordinates of the point. So I had to get the value of k first. Sub k into this linear expression or into this one, and I'll get the same point. So that brings us to the end to finding those points. Again, we found what the value of the unknown was, but we had to plug it back in to find the values of the point. And if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.